Okay, we'll see how well this goes. This is P9, linear inequalities and absolute value inequalities. Okay. First thing we want to hit set builder notation, which hopefully you've seen before, but if not, we'll teach you here. And number lines. Okay. So if you recall, back in the day, maybe you played around with solutions to equations like 3x plus 1 is 5. We solve that thing, 3x is 4, so x is 4/3. And it's easy, we just have one solution, so there's not an issue. But now we're going to have multiple solutions. Okay, so now we may have an inequality to deal with. So 3x plus 1 less than 5. And to write up the solution, we may need a little bit more material to work with. So we'll go 3x less than 4, and x is less than 4/3. So to notate this, you can use their interval notation, of course. And if you don't remember how to do all that, you can always go back to the number line and sort of draw it out. So 4/3 is in between 1 and 2. And we want everything less than 4/3. So in this direction, and this would be the negative infinity side, this is the positive infinity side. So we can borrow sort of the notation. Here's parentheses, the 4/3, all the way down to negative infinity. And you always use parentheses with the infinity symbols. Okay. Okay. So we need to learn, a different ways kind of to handle this. That's my motivation for teaching you this. The set builder notation, then what the heck was that? Well, to rewrite this thing, we would write something like the set of all x such that x is less than 4/3. Okay? Okay, so that's sort of our goal here. We want to get to that point. Okay, so number one, they give you interval notation. So all numbers between 1 and 6, not including 1. So open parentheses mean don't include. Closed parentheses means include. Okay. We'll rewrite it in set builder notation. So this is a set of all x such that x is greater than 1 but less than or equal to 6. Okay, okay, so we read this first part as the set of all x. Okay, so this is two separate words. The set of all x. This line symbol, you literally read it as such that. Okay. And then this explains the criteria that all of these values meet in this set. Okay. Okay. Rewriting that as a number line, we can draw it. Okay. So you don't have to get carried away with too many tick marks. Let's just put a 1 here, 2, 3, 4, 5, 6. And we want everything from 1 to 6. And we indicate we're not including 1 using this open parentheses, but we're including 6 using a closed. And we draw it on. You'd also use, sometimes I see people use open dots and closed dots. Okay. And that's fine too. Okay, let's look at another. This is number 10. We're going from -5 to infinity. So in set builder notation, we would write the set of all x such that x is greater than or equal to -5. Okay? And if you're unsure about the inequality to use, I recommend using the number line. Okay? So you go to the -5, and put a couple extra terms around it, of course. And then we're including -5 and everything above that, all the way to positive. So sometimes people like to write in negative infinity and positive infinity as a reminder, and that's not a bad idea. Okay, so we'll do that. Okay, The second deal we have here in this section is the intersection and or symbols. We'll be focusing mainly on the or symbol rather than the intersection, but usually when you see one, you'll see the other. So we're going to sort of kill them both with one stone, so to speak. Okay, so let's take a look. I want to know the intersection of this interval -4 to 0 with -2 to the 1. And you can think of these symbols as kind of like addition and addition, I guess, maybe. Well, let's not go there. Let's just leave it as it is. Okay, so how am I going to do this? I'm going to draw a number line for each one of these intervals. And then I sort of think of it as adding them together. So the result, the intersection, I'm going to draw a whole nother number line for that. So the first number line is from -4 to 0. Okay, so I want some alignment between my little tick marks, so I do have to make sure that they're going to be good. -4, -3, 2, -2, -1, 0, 1, 2. Okay, and I want the same alignment down here, -4, 1, 2. Okay, so this will be -2 to 1. And then I end up here at this number line. Okay, whatever that's going to be. Okay, so -4 to 0, use open parentheses. -2 to 1, it's right here. The intersection means the element has to be in both of these scribbled in regions to be included in the final answer. Okay, so this entire thing right here, we're going to be putting on this third number line. And for a number to be in this intersection, it has to be in this and in this. So in particular, you can't include -3 because -3 is not in here. Okay, certainly it's in here, but it's not in here. So that's a bad news. It has to be in both for it to end up being in here. So you can see the overlapping regions are kind of your solution. Okay, so we can shade in what we think we need to have, and then the endpoints may be a little different, right? We can include -2 because -2 is included here with the bracket, and it's also included here. It's on the inside. So -2 is definitely included, so use a bracket. And then 1, well, we don't go that far, right? We just go to 0. So 0 is not in this set, but it is in this set. So we can't include 0 because it's not in here. So we end up having to use a parentheses. Okay? So at the end of the day, the intersection of those two sets, hopefully I'm not going off the page here, but that's life, is equal to the interval from -2 to 0. Okay, let's look at a union version of this problem. So 21, we have -∞ to 5, union with 1 to 8. Okay. So the union, if it's in one or the other, it'll be in the union. Okay, so it's not as an exclusive thing as the intersection, right? And for the intersection, it had to be in both. For the union, as long as it's in one or the other, it's in the end union set. Okay, so I'm going to write -∞ to 5. I'm going to put 1 to 8. Okay. And then again, I'm going to draw this third interval as my resultant interval from doing the union of these two intervals. Okay, and I want some alignment going on between my tick marks. Okay, probably going to need a little bit more dense situation. Okay, so -∞ to 5. Let's put 5 right here. No, maybe I should do this interval first. Okay, so I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. Okay, so -∞ to 5, and then 1 to 8. So I'll bracket off 1 and go all the way up to 8. Okay. So that should be a parentheses. And then again, for the final sort of answer, when you do a union, if it's in one or the other, it's contained in the union. So, for example, this guy down here, maybe it's -1. It's in this set, it's not in this set, but that's okay. As long as it's in one or the other, it's still included down here. So you can think of it as kind of like a shadow of, if you had a sun up here somewhere and it was casting a shadow, the resultant shadow is the union. Okay, so looks like we have a whole lot all the way up to 8. Okay, so the union of those two sets will go from -infinity to 8, not including 8. 8 is actually not in either one of these sets. Okay, so why do we care? Well, we care in particular because we're going to use these to write up our solutions for inequalities. And let's look at problem 35. So in 35, we have 4 times x plus 1 plus 2 greater than or equal to 3x plus 6. Okay, so the deal is to get x all by itself on one side of the inequality. So here we go. Distribute. Okay. If you need a number line, you can do a number line. Here's 0. We want everything above 0. We'll go in this direction. And so our solution in interval notation, which is what I'll want on my test. I won't require the set builder notation. Okay, but in interval notation, you'll have the interval including 0 to positive infinity as your solution. Okay. Okay. Next, compound inequalities. Let's look at number 54. We have 3 less than or equal to 4x minus 3 less than 19. Okay. So to work with this, you're just going to work with all 3 sides simultaneously. So if you add 3 to the middle, you have to add 3 to the other 2 sides. So it'll be 6 less than or equal to 4x less than 19, 20, 21, 22. Okay. And then you could divide all 3 sides by whoops, sorry. So, what did I do wrong? I think I made a mistake in my notes. I know I did. Yeah, sorry about that. Anyways, then you're going to divide all 3 sides by 4. So you get 22 fourths greater than or equal to 3 halves. And then we could write up our solution in interval notation again. Okay, so we have 3 halves to 11 halves. We'll just rewrite that, simplifying, and that's it. So fairly easy so far. The next section then is on absolute value inequalities, a little more work. Just do what I say though. Don't try to sort of invent your own processes for these absolute value inequalities. You will get in trouble. Okay? So do what I say. Okie dokie. So the first case is when you have, and this is the hard case, when you have the absolute value of something less than c. And to solve this, what you're going to do is split it into, well, actually you're going to put it into a compound inequality. So you're going to say, okay, this is equivalent to solving the inequality u less than c but greater than -c. Okay. The second type is the harder ones, right? So the absolute value of u greater than c. And in this case, it splits into 2 inequalities. You have to say either u is less than -c or u is greater than c. Okay, there's no way around this process. You have to do the way it's saying to do this. Okay, you can't you can't invent your own process. Okay, so let's look at number 66. we have the absolute value of 3 times x minus 1 all over 4 less than 6. Okay, so the absolute value is isolated. Okay, sometimes we'll have to isolate this thing, and then we can do the process. But let's just one thing at a time, I suppose. All right, so I drop the absolute value. I need to isolate x, so I'm going to multiply through all 3 sides by 4/3. Then I need to add x to all 3 sides, or sorry, add 1 to all 3 sides. And then put my answer in interval notation, and I'm done. Let's try the other version now, 73. Okay. So we need 2 inequalities this time. We need 2x plus 2 over 4 less than or equal to -2, or we need 2x plus 2 all over 4 greater than or equal to 2. Okay. So you have to solve these two completely independently. All right, so you have to solve them. 2x plus 2 less than or equal to -8, 2x less than or equal to -10, so x is less than or equal to -5 over here. 2x plus 2 greater than or equal to 8, 2x greater than or equal to 6, x is greater than or equal to 3. Okay, so we have, whoops, I think I screwed up somewhere, 8, and then we subtracted the 2. Say, I made another mistake in my notes probably. Yeah, I made another mistake in my notes. Gee whiz. Okay. So then x greater than or equal to 3. Right, so over here, less than or equal to -5 means you're going from -infinity to -5, and then we're unioning it with this interval over here, x greater than or equal to 3. So I need a bracket 3 to infinity. Okay, so that's the idea. We'll let you go with that.